Well, you may have seen my video on the Spruce Goose Quad, which was a failed attempt at building one myself, a do-it-yourself build. So I thought I would give it another go, and this time instead of building a large one, I would go with one about half that size. So I found this channel, Joshua Bardell's YouTube channel, has a lot of useful information, very good channel on building and tuning a quad. Got a lot of good information from here and really appreciate all that he's done, all the videos that he's put together to make this doable for me. So the quad that I decided to go with was this ZMR-X210 from FPV Models. So it's a 210 millimeters, about half the size. My last one that I tried to build was a 450 frame. So this one is a lot smaller build, and with FPV, so first person view. So I'm going to just go over some of the parts that I'm using to put together this. I've almost got the quad together and getting really close to the maiden voyage. So I just wanted to give a quick overview on the parts. So first of all, of course, you need the frame that you're going to use. Then the flight controller. So this I bought the version 2.1 flight controller originally, and unfortunately I wired it up wrong. The battery voltage monitor, I reversed the connection, and when I plugged it in, I toasted it. So this was I like this flight controller, but I ended up going with a different one, and this is the one that I ended up going with as I replaced it. I really like the layout of this one, and it's clearly labeled. The VBAT pins, which is what I hooked up wrong on the previous controller, has S-bus, and so you see that the signal pins are here for the motors and the 5 volts and the ground, and it's got the UART pins nicely broken out, as well as the soft serial. So this is a nice flight controller. The only thing I have against it is that when you plug in the USB, it doesn't power the receiver, which the other flight controller did. So that's the flight controller that I'm going to be using. Then this is the data logger. So if you want to do black box data logging, you need a data logger. Although the flight controller does have an onboard data flash chip to log data, I'm going with an external one because I want to use an SD card to make it a lot faster to download the data. So that's the data logger that I'm going with. Now, the brushless motors that I'm going with, there's some numbers associated with the brushless motors. And this website gives some information about what those numbers mean. And here you see that the numbers have to do with the motor's diameter and the height of it, as well as the kV is the revolutions per volt. And so I ended up going with this high kV motor. So this is a 2633 kV motor. So it's a pretty high RPM motor that I'm going to be using. I'm also decided to go with this the FreeSky receiver. So this is the receiver that from your transmitter, this is what's receiving the signal, and it supports S-bus. So S-bus is has 16 channels, so it can take in 16 channels from your receiver to send to your flight controller. And it's a higher speed, more reliable from what they say. So I'm going with that, the X4R SB receiver. The prop, since I'm going with a high kV motor, I don't want a real aggressive prop. So these are 5x4 props, the King Kong props. And here you see the 5x4. What it means is they're 5-inch props, and in one revolution it will travel 4 inches. So that's what this indicates. And so it's not a real aggressive, not a tri-blade. It's not a bull nose prop. So because of the high kV motors, I'm going with kind of a less aggressive prop, and Joshua Bardell talks about this, and he really likes these props. Of course, the batteries, I decided to go with the 1800 milliamp high volt batteries, high voltage lithium batteries. And the thing about these batteries is they're at 206 grams, so this is almost half the weight of the entire quad. But I'm hoping to get a little bit longer flying time with these 1800 milliamp batteries, but I don't know if I'll be able to use them with a GoPro mounted because of the weight. And so I might end up getting 1300 milliamp batteries as well, because if you do that, then you shave off about 50 grams of weight, but you won't, of course, you won't get as long a flight time. So we'll have to see on that. Then these are the speed controllers. So these wire up to the motors and the flight controller to send information, from the flight controller what you want to command the motors to do, and that will give the appropriate power in response to the motors. So I decided to go with these BL Heli, these DYS-XM20A motors, ESCs. And of course, you need 4 of those and 4 motors. For the camera, I'm going with, this seems to be a really popular one, the HS1170, as it's commonly known by right here. You'll find that a lot. And I'm going with the field of view at 2.8 millimeters to kind of get a mid-range field of view, IR sensitive, and a top connector to make it easier to hook up when it's mounted in the quad. So that's the camera. Then you need a way to transmit the video signal back to your ground station, and so I'm going with this SkyZone, this TS5823S SkyZone. That's what I'm going with for the video transmitter. And of course you need the antennas, and these are well, this transmitter is a reverse polar SMA connector, so when you get antennas, you need to make sure you get the right variety, whether it's reverse polar or not. Then you need a receiver on the ground station. So I'm going with this FR623 diversity receiver, and I'll put one of those antennas in place of this, the cloverleaf antennas. And then you need a power distribution board. So this will hook up the battery, and then you can send out power to your flight controller and to your camera and transmitter, your video transmitter. So next, I'll just show you how this all looks when you wire it together. All the components. We'll start. You bring in the battery voltage here, and you can also send up to the VBAT. You want to monitor your battery voltage level, and so you just send that straight up there. But then you also wire the take power. This takes power directly from the battery up to the ESCs, the electronic speed controllers, which then get hooked up to the 3 wires coming from the motor. And so then you route power throughout all your devices. And so this board will send out 12 volts to the camera and 12 volts to the video transmitter here. And then also from here you send up 5 volts to this board, to the flight controller board, and then 5 volts goes to your receiver. So, and of course 5 volts to your data logger, your black box logger as well. So then it's just a matter, so you get power to all your devices, then it's a matter of making sure you're wiring the signals being sent around. And so from here, your camera, your video goes in here, and it will come through the board and be transmitted out. And since this is an OSD, it overlays your on-screen display some telemetry information on that video feed that you'll see. And as well as pulling in from here, you can solder up the received signal strength, the RSSI. So I can pull this off and send that to the OSD as well. So on the screen you'll see how strong your signal is, so you know if you're getting too far, your signal's getting too weak, you need to bring it back closer. And then so these are the S-bus connections here, these 3 pins, well, power and ground, and then the signal going over to here to the S-bus. So that's taking the information from your transmitter, receiving it, and sending it to your flight controller. And then, so your flight controller will decide what to do with that, figure out what it needs to be done in response to that information, and send that signal up to the speed controllers to tell the motors to either spin up or spin down, whatever's needed. Then the telemetry information is all going to be logged, so you can do analysis on it, and Joshua's website gives a lot of good information on that. And then you also hook up, of course, your video output into here. So this will send the information back to your ground station. On the Spruce Goose build that I did, I also was able to hook up, because I didn't have these cameras and video transmitters and stuff. I had extra UART ports up here. I didn't have a data logger up here. So I was able to use the Bluetooth module, and I wanted to hook this up, but I don't have enough serial ports to do that, because then that would allow you to, from your smartphone, install the Easy GUI ground station app and do tuning right there. You just disarm your quad and then connect to your quad via Bluetooth, and then you could tune it. And so I was doing that with the Spruce Goose, and I wanted to be able to hook that up to the soft serial port over here. This was what I wanted to, but unfortunately that can't be done when I'm using S-bus, because of the speed of S-bus. It can't keep up, can't do that. So that's the setup, that's the wiring for how this is going to be put together. And then real quickly, I'll just show you, I've got it set up, and I've got the quad plugged in now to the USB, and so I've got it set up. This UART1 is for the serial port, what I'm connected to right now through the Betaflight configurator. And then when I arm it, this port since this port won't be needed when it's in flight, when I arm it, it'll start doing the black box logging out the UART1. And then you see UART2 I have set up for the S-bus, the serial port, and then I have the UART3 set up for the smart port, which is gonna the telemetry. And so the configuration then, these set up your throttle range. Here I have the serial enabled and the S-bus protocol for that. Do the battery voltage monitoring. I'll be using the PID is the PID loop frequency is the frequency that's doing the calculations on what corrections need to be done, taking the measurements of what your stick input is and what the quad is doing, and the calculating the error and how to respond to that, and the gyro frequency, how often it reads the input on what the quad is actually doing. And then so I'm enabling these features, telemetry and the black box and the error mode. For failsafe, I enabled failsafe, and if I lose signal, then it'll just drop. Not continue to fly or not try to land, just drop. So these settings are what Joshua's website has tons of videos on how to tune and how to tune these values for correction and dealing with oscillations, things like that. And he's using these rates. So what this does is, as your stick moves further from the center, you want more and more aggressive response of the quad. So you kind of start out as a soft response, and the further away you get, you want a more aggressive response, and that's what that shows there, and that's what this rate sets. Of course, the receiver I don't have plugged in. The modes, I have a beeper set up on these auxiliary channels, a channel to arm, and black box logging, and then black box I have set up to log. So that's about it. Thanks for your time. Thanks for watching.